All right, we are moving on to subtracting mixed numbers. And then the next video we will subtract mixed numbers using borrowing. So the first thing when I look at my subtraction with mixed numbers, I actually do this when I'm adding my mixed numbers also. I like to set them up and down rather than side to side, because then I can break down into my fractions and into my whole numbers, because if I cover up this, it looks like a subtraction problem with my fractions, and if I cover up that side, it looks like subtraction problem with my whole numbers. For me, I like to see that because then it shows me what I'm actually looking at, and it's a lot easier just to cover this up so that I can focus just on the fraction part of it. When I'm doing my subtraction, I look at the fractions first, because there will be times when you're subtracting that you need to borrow, and if you subtract from your whole numbers first, it's a little bit harder when you're borrowing. So first thing we have to do, we need to look and see, do we have the same denominator? So 4 and 8, we do not. However, we can get there very easily. My common denominator for this one happens to be 8. Okay, so just like we did when we were subtracting and adding with our just fractions instead of mixed numbers, how did I get from 8 to 8? I multiplied by 1. So I'm going to do the same thing with my numerator. So that one does not change. And how did I get from 4 to 8? I multiplied by 2. So I'm going to do the same thing with my numerator, and 3 times 2 is 6. Now for this, my whole number stays the same. So my 3 stays, my 1 stays. So now as we go through this, here's your new problem. Okay, all we did was we just changed this fraction by multiplying by 2. Now looking at this, if I focus on just my fraction part, 6/8 minus 3/8, I can do that, and I end up with 3/8. I did not need to borrow. So this stays 3 minus 1 is 2. So my final answer for this one is 2 and 3/8. All right, the next one. We have 4 and 5/8 minus 1 and 1/3. Okay, first thing again, we need to find a common denominator. And looking here, we have our 8 and our 3. You cannot take 3 times anything to get to 8, so that means that we need to change both numbers. So again, if you looked at your multiplication chart, if you looked in your 8's column, and we looked in our 3's column, where we're looking for the number that is the same there. And our first one that we find that is the same is 24. So my common denominator here is 24. And how did I get from 3 to 24? Well, I multiplied by 8, so I'm going to do the same thing to my numerator. And 1 times 8 is 8. And how did I get from 8 to 24? I multiplied by 3, so I'm going to do the same thing with my numerator. 5 times 3 is 15. And my whole numbers do not change, so my 4 stays and my 1 stays. And I end up with 4 and 15 24ths minus 1 and 8 24ths. So again, I can focus on my fractions now. Can I take 15 24ths minus 8 24ths? Yes, I end up with 7 24ths. And then I have my 4 minus 1 is 3. All right, and the last one. We have 5 and 2/3 minus 2 and 1/2. All right, looking here, again, we need to find a common denominator. I cannot take 2 times anything to get to 3, and I cannot take 3 times anything to get to 2, so I need to change both of them. If you look at your multiplication chart, you will see in your 3 column and your 2's column, the number that is the same, or the first number that's the same, is 6. So my common denominator is 6. I took 2 times 3 to get to 6, so I'm going to take 1 times 3, and I end up with 3. And I took 3 times 2 to get to 6, so I'm going to take 2 times 2, and I end up with 4. And just like the others, whole number stays. So now I can look at my fractions. 4/6 minus 3/6 gives me 1/6, and 5 minus 2 is 3. And my final answer there is 3 and 1/6.